all the functions and variables we have declared so far are what we call instance members. So these members belong to instances of the rectangle class. So each instance is going to have its own copy of these members. But we can also declare members that belong to the rectangle class itself. So we will have a single copy of these members in memory, and that single copy will be shared by all instances. We refer to members that belong to the class as static members. So let's look at a real example. Back to our header file. Here in the public section, I'm going to declare a static member variable for counting the number of rectangle objects we have created. So we type static int objects count. Now earlier I told you that we should not declare our member variables in the public section, but let's temporarily declare this variable here, then we'll come back and move it to the private section, okay? So here's our variable declaration. Now whenever we declare a static variable in a class, we should always define it in our implementation file. So back to our implementation file. Anywhere in this file, we need to define our static member variable. So int rectangle double colons objects count. And here we initialize this to 0. Now we're going to go to one of our constructors. Let's say this one that takes 2 parameters. Every time this constructor is called, we know that we're creating a new instance of the rectangle class. So here we can increment objects count by 1. Now technically we should do the same thing in other constructors, but let's not worry about it at this point. Let's just see how we can work with static members. So now back to our main file. We have 2 rectangle objects. Let's print the number of rectangle objects we have created so far. So because static members belong to the class, we cannot access them via class instances. So if we type first.objectsCount, yes, we can see this, but we get a warning saying static member accessed through instance. This is not the right way to access a static member. So here we need to type rectangle, and instead of the dot operator, we type the scope resolution operator. Now let's add an endl at the end. So take a look. So we have 2 rectangle objects in memory. Great. So we have a single copy of this variable in memory, and this copy is shared by all instances. Now let's apply the data hiding principle. So we're going to move this to the private section and provide a getter for accessing it. So back to our rectangle header file. I'm going to cut this from here and move it to the private section. And by the way, when declaring static members, always group them together. This makes your code easier to read and understand. Don't throw static members all over the place. So you can list them all after instance members. You can also separate them using a line break. So here we have a static variable. Now let's generate a getter for it. So in the public section, again, I'm going to put my static function at the end. So static int get objects count. Now let's generate the definition for this function. Good. Now, because this function or this method is a static method, we can only access static members here. So if we try to access the with, we get a compilation error saying invalid use of member with in static member function. So in static functions, we can only access static variables. And that makes perfect sense because this function belongs to the rectangle class, so it doesn't know about any rectangle instances, right? So here we're going to return objects count. Good. Now back to our main file. Instead of accessing this private member, we're going to call get objects count.